recording now? God, I hope it hasn't been recording all this time. Anyway, we're going to go back here and I'm going to go over Unit 2, right? So, what I want to do here is come over here and I am going to go to the notes and show you, just like I said, here's my Unit 2 notes. And this is what we're going to follow when I am. This is what you're going to see, and this is what I'm going to lecture on. And I know, unfortunately, it's not very good for you, and I don't know how to get that any better, but we're going to go through this, right? So, basically, this is nothing new to you right here. This is what we call a histogram, and oftentimes people confuse it and refer to it as a bar graph. Though they are extremely similar, the one difference is in a histogram, the bars touch. In a bar graph, they do not touch. So this is, and this gap here is only because, not because there's no bar here, but there's nobody that scored in this interval. So it's zero, right? So there is a bar there. It's just not that you see. At any rate, this is a pictorial, right? A picture of our data, right? We talked about the tables, we did this, but we also have pictures. We develop pictures of our data, and the histogram is one way we do it. And you've seen these, like I said, I'm fairly confident you've seen something like this before, right? And then another one that we use is a polygon, and I don't know why. Let me get Oh, I guess I'll have to make it smaller actually. So, and then of course you can't read it, but basically the polygon is I've taken my data and I've plotted the points where it belongs on the graph, right? These are my scores across the bottom, and this is the frequency or how many people made that score, right? So I have one person that scored a 15 and I put a dot right there where the 1 and the 15 coincide. Nobody scored a 16. Two people scored a 17. And you'll see this clear on the notes when we're looking at them. I'm sorry, I can't get a better picture. Um, and then five people scored an 18. Eight people scored a 19, right? And and then we use those dots and we just connect the dots with a line, and that's how we get our polygon. Right? Now the difference is here we put from 14, we have this dotted line. We always put one score below the lowest score and then one score above the highest score. And we connect that with the dotted line. Don't ask me why. I don't bother. I don't know what the theory is behind that, and you probably don't interested anyway. So, but that's how you draw it. Okay, just so you know. And what happens is I'm not going to ask you to draw this, right? But I am going to have. There's going to be questions about it on the test. This is the same thing, only here, and you can't see it very well, unfortunately. These are scoring intervals, right? So we talk about when you have a large variability in your scores, you can't list every individual score because you can't. Your horizontal line cannot go on forever, right? So you do scoring intervals, and here we have 6 to 8, 9 to 11, right? So what we plot is the midpoint. So it's 6 to 8. We plot 7, right? And 4 would be the lowest score below 6 if you're doing right. So, um, and the same thing. This 9 to 11, we plot 10. Okay, and so whatever number of people got into this interval, which is 1 here, right? That's all we do. So we take the interval and we mark it here with that number that we decided, which is the midpoint of the interval typically. Okay, I know, but I hope that makes it clear. Okay, so Those are histograms and bar graphs, right? So this line, the y-axis, the vertical is ordinate, right? And typically is the frequency. How many people scored in this range? How many people made this score? How many people did whatever it is we're measuring? Then the x-axis is called the abscissa. Don't worry, I don't use that language anymore. And that's the x-axis, which is the horizontal axis, which is typically the scores. Okay. Uh, so like I said, the graphs with polygons are the graphs with points or midpoints. And I'm guessing you've seen stuff like this before. I'm not going to stick on it too much. Okay. Here, I'm going to start talking about the bell curve, right? So, excuse me, I'm going to refer to my own note. This is another drawing. This is the drawing you are going to see the most throughout the class. Like you're going to see this from now on, just about every lecture, at least once. This is the bell curve, and this is what we call the this is a theoretical model of what we say happens if you um, study an entire population. So that's what we're saying. Do you study an entire? I wonder if this will. Oh, no, I screwed it up. I can make this a little bigger for now. All right. So this is the bell curve. And hopefully while you're watching this lecture, probably the recommendation is that you have you either have a printout of this or you have it on another screen that you can see better, right? And follow along with the lecture. I think I mentioned that in Unit 1 too. So this is the bell curve, and this is the curve that we call the normal curve. It is the normal curve, but most people refer to it as the bell curve because it's shaped like a bell. And this is theoretically how with the outcome of every study. If you study an entire population, and don't worry about what that means. We're gonna go over what that means later. But I want you to familiarize yourself with this shape. The next thing the next thing you're gonna see is what we call skewed skewed tables. And so if somebody has a that's as big as it's going to get. So this is what we call a negative skew, right? And what I mean is like most of the people you can see scored here, but unfortunately one or two people, which we will call outliers, which you'll learn more about later, you'll hear again, is scored very low. And so it's this table has a negative skew to account for those people, right? This is what we call a positive skew, and it's the person it's those two people in your class that threw off the curve when you were getting graded by a curve. I don't do any of that, but these are the people that threw off the curve. They got a very high score compared to the majority of the class. A positive skew has the tail going to the right or towards the positive scores, right? You'll see here this is 0 and this is the positive side of the curve. And so same here, this is the positive side of the curve. And you can't see it too well here, but this is dotted line as like represents the mean, or the median in this case. I'm going to get to that. And so here, the tail goes off to the left or towards the negative side. And so the curve is named for where the tail goes. So negative and positive skew. Okay. Then we have, this is the last one, and it's not by means the only one, a bimodal distribution, meaning there are more than two modes. And we're going to learn about modes right now in a minute. Okay, so if you don't know what that means, don't worry, you will in a minute. So the curve can look like this, right? So we're going to talk about this. So all of this, when I said that, the mode, and then and I said here about the median, right? And I'm going to tell you right here, this line represents the mean, median, and mode, and is perfectly symmetrical. bell curve, right? Um, what are those? So mean, median, and mode are what we call our, to shrink this, I'm sorry. Mean, median, and mode are what we call our measures of central tendencies. Start writing on the board. So that's what happens. I don't think I can do both. So anyway, I got this problem laid out here for you, and I'm gonna do it, or I'm gonna do it live right now for you, right? So this is the mean. This is the average. When you hear the word average, this is the most common uh, form of average that we measure, and it's basically the average of all the scores and how you get that. And so you can see the formula, not very well, but the mean is the sum of x, and that symbol, we've been through the symbols, you have a thing of the symbols, that symbol is sum, and you're going to see that repeatedly right throughout the class, and I'm sorry. You see, there you go, it's a little better. You're going to see that, right? So, and then over, so it's the sum of the scores, x, over n, the number of people in, or the number of subjects. Okay. So we compute that, right? And I'm going to have to shrink it again. And I'm going to close this, or rather, I'm going to bring this up. Okay. Now I want to, you see, hopefully this is going to work, right? All right. So, all right, let me, I got m, right, equals sum of x over n. Sorry, but I'm not I'm not getting a whole lot better at this. All right, so, and my scores are 1, 2, 3, 4, 5. All right, so now m is equal to 1, 2, plus 3, plus 4, plus 5, right? Over my number of scores is 5, right? So this then is equal to 15 over 5, which is equal to 3. And I do the 3.00, and hopefully I'm not going to bother to erase that. Because what I'm going to tell you is I want all your answers to include 2 decimal points. In almost all your practice throughout this class, your answers and your numbers should include 2 decimal points. All right? And that's how we do the means. Obviously, that's a very simple example, but it's the example that we have. So now, onto a blank thing. And I'm going to drop this down again and go back to my notes, right? So that's the mean. All right? The next thing we're going to talk about is the median. And the median is the middle score. It doesn't matter what it is, but the median is the middle score. And I have no thing for that, right? I'm going to go back and show you, like I said, in this perfect square, the median is right here. This is the middle. Right? It's exactly the same on this side as that side. Here, it's a little bit different because of the skew. And we're going to talk about the fact that the median is the best average in a skewed curve, right? And we're going to get to that in a minute. So that's the median. It's the middle score, whatever that is. And it does not get skewed, right? So we're good. And the median is, so I guess I'll do this, right? So say we had our 1, oh, I gotta go back to this again, sorry. Say we had our 1, oh, 2, 3, 4, 5, right? The middle score in this case, when there's an odd number, it's very easy to fix, right? The middle score is the middle number. If it's an even number, it would be between 3 and 4, and in this case, it would be 3.50, right? Okay. But like I said, in a symmetrical thing, which is when you have the five numbers, which is symmetrical, I will say, because, right, it's, oh, that worked really nice. I like this. Um, right, when it's in this is symmetrical because there's two scores below and two scores above. All right, so hoping this helps. All right, and next we have the mode, and the mode is the score that shows up the most, right? And so if you have a long list of scores, a lot of people get the same score. But what score did the most people get? That is the mode, right? And you'll be seeing this down the line, okay? So that's mean, median, and mode are measures of central tendencies. Okay? That's we're going to be working with that a lot, right? So, I know this is hard to read, but we're going to do the best we can. I can't blow it up too much because then it goes off the side. So we have a bell curve, and as I said a number of times already, with the bell curve, the mean, median, and mode are all in the same place, right at this high point in the curve, right smack in the middle of the curve, right? Because that's where the median is, in the middle. In the bell curve, all average central measures of central tendency or averages are valid and good, and they all work. However, if you have the skewed ones, it's the mode that is the most effective. What is the score? What is the score that is the most, right? Because of the skew, the middle doesn't matter because it would end up to be somewhere over here, right? And the mean doesn't matter because it's thrown off by these two. It's thrown off a ways because of this, right? But it doesn't necessarily represent all these other people, like everybody validly, right? So when you have a skewed curve, you use the mode, then the median, and the mean would be the last thing you'd want to use. Right? Same thing. If it's positive or negative skew, it doesn't matter. You want the mode is the first thing you would rely on, the median next, and the mean last. Okay. So hope that works. Because these are the base. We're going to be using this language, and we're going to be using this stuff a lot. Okay, so please, as I said all the time, if there's any question, get to me quick because this is the building blocks. Everything goes on top of this. Um, now we're going to talk about variability, or really the word we use the most is range, right? And so literally, you would you subtract the lowest score from the highest score, and that's what we call the range. The weakness with the range is outliers. And remember, I talked about that. I'm going to go back to that. We call these people outliers because they're way far away from the group. Right? So they're outliers. Definition pretty self-evident, right? They lie outside of the group. And so outliers can affect the range, right? And so here we go. So I'm gonna hang on. I'm gonna do a little demonstration, I guess. I didn't need to. Ooh, what did I do here? All right, I'm gonna try this. Okay, so here's this. Oh, sorry, I keep writing off the wall here. 2, 4, 6, 8, 24. All right. So if you look at the range here, right, then we're talking about 24 minus 2, which is 22, right? And the range is 22.0. But that doesn't really represent it, right? Because this is the scores that came up the most, right? So that's why we say the range can be affected by outliers. Meanwhile, if I erase this 24, and I just look at this, right, and it becomes 8 minus 2, right, it's 6, which is a total of very big difference, right? So if there are outliers involved, again, let me get this right. Oh, look at this. I'm feeling good about myself about working this stuff. So, so if there's outliers involved, what we're going to look at is not the range, but the what we call the interquartile range, quarters. So we're going to be looking at the two middle quarters, which would eliminate any outliers, right? Because if I go back here, and I go back, let me see where I am, all right, and I add this 22 again, so let's say, right? Oh, there's not very many scores. So there's 1, 2, 3, 4, 5 scores, right? And so it's 1 1/4 scores for each quarter, right? And so this isn't a very good example. I'll do the other one. We'll get rid of it. Oh, gee, oh, sorry. And it was off. All right. So we're gonna let me see here. Sorry, I lost track. I'll turn my phone off. So we're going to talk about the interquartile range, which is the range of the middle 50% of the classes, right? So 1/4 is 25%, so we're looking at the two middle quarters. Okay, so I want to show you here, right? And I'm going to do this in vivo. Let me get to my problem. And the reason this works, and I'll show you. So let's see. Got a new one here. All right. So the reason this works, so let's say my scores are 4, 6, 8, 9, and 12. I gotta read my notes here, that's why. 14, 16, 18, 20, and then 202. Let me say that, and I'll fix my notes over here. It says 22. It's supposed to say 20. I'll fix that. All right, right? So here's our outlier who would change the range to the range would be 202 minus 2 would be 200, but the real range of the scores is nowhere near that, right? There's this one score that's skewing that and doing all that. But what we're going to do is look at that interquartile range. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 scores. So how do we find quarters, right? We divide by 4. We want to know. So we have 12 scores, and if we divide by 4, that's equal to 3 scores, right? And this is one case where you wouldn't have to write 3.0, but I'm just wanting you to keep seeing it. So what I would do is over here, move in 3 scores. Over here, I would move in 3 scores. And now I have these two middle quarters, right? So this one's 3 scores, 8, 9, 10, and then the second one is 3 scores, 12, 14, 16. And now what I'm going to do is find the range of those two quarters, which is 16 minus 8, which is equal to 8.0. Right? Hopefully that makes sense, right? We don't use the interquartile range much in the class, but I need you to know what it is and what the function of it is and why it's there, because this is your first, hopefully, statistics class. You're going to want to know that. All right? So that's the interquartile range. All right? And there'll be questions on it in the test and the worksheet. Please, I'm going to repeat this every unit. Do the worksheets and get them done before you start working on the exam so you can see your grades. And if there's stuff you're not understanding or you think you should have got right, you get wrong, you can talk to me, right? So we can get that worked out so you get a better grade on the exam than you do on the worksheet. Okay? All right. So now the last issue for this unit is where we start delving into some real math. Um, and that is going to be standard deviation. And so we'll talk about all these formulas, but the standard deviation, what we're talking about is the standard deviation from the mean. So in every curve, there is what we call the standard deviation, and we calculate that based, and I'll show you the arithmetic in a minute, right? But here in this bell curve, right, we have one standard deviation right here, 2, 3. And it goes a little bit further, but for the most part, really, we limit our discussions to 3 standard deviations from the mean. Here's the mean. And it tells me where anybody might be compared to that mean. So you want to know if you want, what is the individual? Where is any individual in relation to that mean? Am I above average or am I below average, right? And hopefully we're all shooting for above average, right? But anyway, that's what the standard deviation. So the standard deviation gives us a measure, and then any individual score is a multiplier of that standard deviation. And we're going to talk about that too, so don't worry. All right. And you don't have to figure that stuff out. There's pretty much a table for it, and we're going to work on that. Okay. Later. That comes down the road. But right now, I just want you to understand how to do a standard deviation and compute the standard deviation. So we have all of these formulas here, right? So this is what I say for a sample, and this is for a population. And let me just briefly go over the difference, and we're going to talk more about this later. But a population is anything I define, right? We talk about the population of the United States, the population of California, the population of Delta College, the student population, and even the student population of Delta College, right? So I'm not going to be able to do research and contact and talk to every student at Delta College. Like, that's probably not a realistic goal. I could do it if I figured, but it would be way too complex. So we normally don't study populations. We normally study samples of the population. And so this class could be a sample, like you guys are a sample of the population of Delta College. You're not one I would really use in an experiment. We're going to learn more about that later when we talk about sampling and stuff. But what I want you to realize is there's a difference, and we typically study samples in our research because to study a population is very challenging. Okay? So, this is it. So we're going to work on this formula right here. This formula and this formula is the same. This formula here, however, is if you have multiples of the same score, and when you see the math, you'll realize why. Hopefully, and I'll come. But right now, we're going to focus on this, okay? And like I said, so this is the same formula, only here we use the symbol instead of the X with the bar to represent mean, right? So that's what this is. The X with the bar is the mean. We use this mu sign as the average mean of the population, whereas this is the mean of the sample. Okay. Let's see. So I have some computations here. We're going to worry about that later. Okay. But we're going to do some standard, we're going to compute a standard deviation. Okay. So let me see. Now I'm going to do this. Okay. So basically, I'm going to get rid of this and I am going to bring back up my whiteboard, and I'm going to write this out for you, and hopefully while I'm writing and talking, it will help you. Anyway, so we're going to start with a list of scores, right? And our scores are 10, 11, 11. Let me get 13, 13. Where am I? 14 and 19. And those are my scores, right? And so now, I have to get there. There we go. 19. So there's our scores. So the first thing I need to do, right, is I need to know what is it I need to know. I need to so this is X, right? Now I need to know the mean, right? And we know how to do this is the sum of X over N. So we're going to do 10 plus 11 plus 11 plus 11. So I keep wanting to do the comma. 13 plus 14 plus 19 over what's n? 1, 2, 3, 4, 5, 6. Right? And in this case, what we want is n minus 1. Oh, this is the mean. So we just want n. So this is equal to 78 over 6, which is equal to, I'm sorry, running out of board, 13. Right? So m equals 13. That's a dot, not a comma. Sorry about that. All right. So now, when you go back to the formula, right, and so I'm going to move over here. I'm going to be jumping back and forth between here, right? I'm going to do standard deviation is equal to, right, the square root of the sum of x minus x bar, or mean, squared over n minus 1. Remember again, this is for a sample, and in the questions and the worksheet and the stuff I definitely differentiate and remind you sample versus population. So this is the sample. So what does this equal? How do we do this? So first, we need to compute what's in the parentheses, right? So we need to know what each of these is. So we're going to actually do a table. It's going to be x, and then it's going to be x minus m, right? The variance, the deviation, the difference between the score and the mean, the difference between the score and the mean. And then over here, we're going to have x minus m. Oh, and I guess I should use the same symbols. I'm sorry. Let me see how to do it. That's my fault. I should be consistent. Instead of writing what I'm saying, I should write what I'm saying. So this is x bar, right? And this is x squared. So how do we do this? So we have our scores, right? We have 10, 11, 11, 13, 14, and 19. And don't worry, if you ever go any further, you're not going to be doing this math. There's software, there's all that stuff, right? But you need to know what the software is doing for you to be able to program something or utilize it or understand what it's saying. So I'm going to keep these as simple as I can. So here I have 10, right, minus 13. And I put the decimals, but I'm running out of room, which is -3, right? Here I have 11 minus 13, which is negative 2. 11 minus 13, which is negative 2. And this is where I will go back and show you the other formula where I would actually be able to just multiply this answer by 2. But for our purposes, we're just going to stick with this. Right? So 13 minus 13 is 0. 14 minus 13 is 1. Right? And 19 minus 13 is 6. So it doesn't matter, right? Once you square it, this becomes 9, this becomes 4, this becomes 4, this becomes 0, this is still 1, and this is 36. So when we go to our formula, right, we did this, and we found the square. And now, but it's asking for the sum of the squares. So what does that mean? That means I have to add these up. So 13, 17, 18, 54, I believe. Yes, 54. Gotta check. Start adding it there. All right. So that's the sum of my squares, right? So what does that mean? So now I go over here and it's SD, and now I'm looking for the square root of 54, right? That's 54 is what that whole top equation worked out to be. Over n minus 1, which in this case is 6 minus 1, and I'm guessing I could have avoided that, which is equal to the square root of 54 over 5. And because this is a score, I'm including the decimal points. Because this is people, I don't use decimal points, right? Because I'm not going to have part of a person. Then I do this, right, is equal to the square root of n.80, which is equal to 3.29. And that is the standard deviation for this group of scores. Now, what does that mean? All right. So hopefully you followed that. If you have any issues, let me know. If not, all right, so now I'm going to go back to my notes here for a minute, okay, and say, so what does this mean? So what it means is when I go back up here and show you this picture again, right, this is the one standard deviation. Omega is the sign that they used here. I wrote the SD. It can be whatever you label it. Right? So we're gonna, we'll talk about labeling. So one standard deviation. So in this case, the mean would be 13. Right? And we're gonna go over this a lot too. The mean and median and mode would be 13, right? And then one standard deviation above the mean would be 13 plus 3.29, right? And so if your score was between 13 and 16.29, right, 13 plus 3.29, then you would be equal to or less than one standard deviation above the mean. And that above and below is going to become very important. Say I scored a 10, I would be in this section, wouldn't be exactly right. So this would be 13 minus 3.29, which would actually be 9.71. And we're going to do this more. I shouldn't even be bothering with this right now, but I'm getting ahead of myself. But I want you to know, right? So if I scored a 10, I would be right in here. And I would be within one standard deviation below the mean. And that's going to become very important to you later. All right, so that is the case for distinguishing the mean. All right? The standard deviation. Sorry, that is how you do the standard deviation. And in the worksheets and the exams, I didn't get much. I don't think I got beyond 6 scores, whatever the case may be, right? But now I want to talk to you about the rules, okay? And that's why this is all marked up like this. Right? And let me see if I can zoom in and help it get a little better. All right, so you can see it a little bit better over here now. I am going to, right? So here's the mean, median, and mode, like we said, and this is one standard deviation above the mean. The normal and the bell curve, 34.1% of the people lie between the mean and one standard deviation above the mean. Another different 34.1% of the people lie between the mean and one standard deviation below the mean. It says 34.1. We typically talk in terms of 68%. 68% of the people, an exam, a quiz, a survey, whatever the case may be, if we study the whole population, 68% of the people lie within one standard deviation of the mean. When I say lie within one standard deviation of the mean, that includes the one from the one below to the one above. It's actually two standard deviations that we're talking about, and that's why you add these together for 68%. And that's the rule. So here's some of the rules. We're going to go back to the rule. Here's the rule one. 68% of the cases fall within when the rules for a bell curve or the normal curve and a standard deviation, 68% of the cases fall within one standard deviation of the mean, and that's what I just demonstrated, right? That's what I just told you. I don't know how well I demonstrated. Now, 95% of the cases, sorry if I'm making you dizzy, 95% of the cases fall within two standard deviations of the mean. Right? So here, 95%. So if you add 34 and 13, right, you get 47. Right? And here you get another 47. If we include the things, it comes out to 95, right? So we have 68 here, and we have 26 here. It's like 94, but when you add the little decimal points, then we're talking 95. So 95% of your cases lie between here and here. All right, that's the approximate 95% rule. But we're going to, and then there is, so we're not going to get it. Then 99.7%, almost 100% of your cases lie within three standard deviations of the mean. And that's why I said we rarely discuss this people because these are typically the outliers. Right? So 3% of your people lie. Actually, 1.5% of your people lie out here because 1.5 lie over here, and then here it says actually 0.1. So this, but that's a different part of the picture. So I want you to understand: 99.7% of the people, whatever we studied, fall between these three standard deviations of the mean. And when I say that, it includes above and below. Okay. So that's those key words, above and below, because of the questions and the tests, it makes a difference, right? So then I referred to what I also called as the precise 95% rule. So really what it means is it's not quite two standard deviations, it's 1.96, which would be like right along here somewhere and cut out a few people. It's the precise 95% rule. And I'm saying that because, right, when you read your questions, when you're doing your worksheets or your exams, it makes a difference whether I say for the 95% rule or the precise 95% rule. Changes the question. Okay. So that's 1.96 standard deviations instead of the two, right? And the 99% rule, right here, I talked about 95 being 3 standard deviations, but really what the more precise is 95% fall 2.58 standard deviations from the mean. Okay? So, now remember I talked about where I'm going to lie in the thing, right? So what does that mean? Like very few people lie exactly on 1 standard deviation, right? We're anywhere inside that curve. So we want to talk about the multiplier. So we're going to get into this. So if I have uh, so the 95% rule, 1.96, it becomes my multiplier for the precise 95% rule. I'm sorry, I got a little distracted because I was trying to read ahead. So I have a standard deviation, let's say, of 4 and a mean of 44. Right? I'm trying to make this simple. Then 1 standard deviation, 95% of the people, right? 1.96 times the mean, rather times the standard deviation. 1 point is actually 7.84. Right? So 95% of the cases, this is then becomes my new, this is instead of just 2 standard deviations, which would be 8, right? I use this 7.84 for the precise 95% rule. And then what it would be is my mean is 44. Minus that, right? 95% of the cases would lie between 30. The low score would be 36. I subtract that from the mean. And the low score would be 36.16. And I would add it to the mean on the other positive side, which would be 51.84. So therefore, 95% of the cases lie between the score of 36.16 and 51.85. And we're going to go over this more. I'm going to fix my notes here to help you, hopefully help you out a little bit more, right? Sometimes what I write and what I say is 2 different things. So that's why you have to listen to the lectures and not just read the notes, because my notes are just a reference point. Right. Anyway, I will clean this up a little bit, hopefully. At any rate, that is the end of Unit 2. We gotten into the math now. We got into the math, but I simply demonstrated just right. Addition, subtraction, multiplication, and division. The only thing you had to do was the square root, and you got a button for that on your calculator, right? And squaring is on your calculator. If it's not, right, it's very simple. 3 times 3, 4 times 4, 0, 0, whatever it is times itself. Okay. So, uh, please get to me. If there's anything you have questions about, reach out to me, please. I'm going to post, I got the information about the tutoring, so I'm going to post that in an announcement. And I hope this helped, and good luck. And